So with, the previous versions of SSL and TLS, and they've been around for quite a while now. We've been able to decrypt these protocols as long as we either had control of the server or the client. Is that correct?
So the way that TLS decryption works for any version of TLS, you either need to have some control over the server or some control over the client. And the control means that you can do two things. You can convince the user that you are the server that is really being talked to, so you can handle the authentication, but you can also get hold of the session keys for the session so that you can decrypt the user data. And really the two techniques that are in use are dependent on which end you have some control over. So if it's an employee, if it's a customer coming in to talk to your server, you obviously control the server. It's easy to get a copy of the server's TLS certificate and its private key and install that on the device that's going to decrypt the traffic. And that means that for the user, it is the server. It authenticates very easily and you can decrypt. And with versions prior to 1.3, you could do that type of decryption passively. So you could, if you have the server certificate and key, you could work on a copy of the network packets and do decryption. That's what we call non-server key decryption. But the other use case is it's your employees inside the organization going off to TLS servers that are on the internet. They're going to Gmail or Facebook or something. And in that situation, we need to use a different technique to get visibility, because the server certificate that comes back from Gmail is what the user is expecting to see. And in order to do decryption, we need to modify that server certificate and send the modified version to the user. But the user's browser would typically reject that and say it's not a trusted destination anymore, unless we install an enterprise certificate authority in the encryption device so that it can use that to sign the modified server certificate before it sends it to the client. And the client trusts the enterprise CA, so it trusts the modified server certificate. So that gets us over the authentication hurdle. But in order to do that, we obviously have to be in line because we need to modify the traffic between the server and the client. So for that certificate resign visibility mechanism, you always have to be in line no matter what version of TLS you're running.